Alright, welcome to our sixth video. This one's on solubility constants, KSP, sometimes called solubility products, and it is, well, a very short video. So, when a solid is placed in water, it will reach an equilibrium through dissolving. Now, the equilibrium constant for the dissolving of slightly soluble salts is called its solubility product. So, it's basically just a special type of equilibrium where we're about to talk about this. The reactant's always a solid. But, well, let me get to the next slide, actually. KSP is the K you're doing. It's calculated the exact same way as a solid, but your reactants will always be a solid, and the products will be that reactant associated. For example, if I have calcium fluoride, and I want to find the KSP for it, that's going to turn into calcium 2 plus 2 F minus. Okay, it always associates, and then this is a solid. So, a couple things to know. The bigger the KSP, the more it can dissolve. Because remember, K is products over reactants. So the bigger my value, the more products I'm going to have, which means the more I'll dissolve. We often are going to call the solubility of this our molar solubility. Which is measured in moles per liter. Which, by the way, if you take out the soluble of that, you get molarity. Molarity is basically just molar solubility. So, anyways, let's do an example. So copper 1 chloride has a solubility product constant of that and dissolves according to the equation that is not currently given to you. Sorry. Copper chloride. That's supposed to be solid. Turn to copper and chloride. Alright. So we're saying, what is the molar solubility of this salt in ocean water, in which our concentration of chloride is 0.55 molarity? So, the thing you gotta know is that KSP represents the relationship that we're gonna have between products and reactants at equilibrium. So, what we're gonna do is basically we're in ocean water, and there's already some chlorine in there, which is going to affect how much of the stuff is actually going to dissolve. It's like trying to add more salt to salt water. You know, you're going to hit a point where you're going to be able to dissolve less and less. So they're saying, if we already have 0.55, how much of this stuff are we going to dissolve? Well, let's look at this. Our KSP is equal to copper times chloride. We don't put copper chloride in because it's a solid. So, we know this number. We're going to use this number for chloride, and we're going to solve for copper plus. That will tell us how much copper is able to dissolve at this solution, at this situation. And that basically is going to be our answer. It's not quite, and I'll show you technically what we're doing. But we have that. So we got kind of all this work. Sorry to kind of throw it all at you, but let's kind of walk through this. These are our numbers plugged in, and this is basically our final answer. This says that in this situation, when we let this reach equilibrium, this is our concentration of copper plus that we'll end up finding. Now, typically, this will be your final answer. Because ultimately, we're looking for the molar solubility of copper chloride. What you got to look at actually is stoichiometry. And you realize that all of these have the same coefficient. So, what that means is that, in essence, if we treat that number as moles, then we're going to have the same number here. And that's actually our final answer. Let me walk you through this again, though. We know our KSP, and we know that in this situation, we've already got some chloride. So we're trying to figure out how much of this is going to dissolve based on the stuff that we already have in there. So we set up our KSP, plug in our values that were known, we get copper, and then stoichiometry tells us that's actually the same number for our original salt. And that's it. It's basically just a fancy way of solving for K. It's just whenever you hear molar solubility, they're meaning the concentration of the original compound. That's KSP. Thanks for watching.